In this video, we're going to talk about even and odd functions. In this video, we're going to talk about even and odd functions. An even function is symmetric with respect to the y-axis. So this means when you input a negative x into the function, you get out the original function. And an odd function is symmetric with respect to the origin. So when you input a negative x into the function, you get out a negative of the original function. For example, if we are given f of x equals x cubed minus 2x, we would start by drawing a rough sketch of our graph, which will give us something like this. So looking at this, it appears the function is symmetric with respect to the origin. So let's test this algebraically. We insert a negative x into our function, which gives us negative x cubed minus 2 times negative x, which simplifies to negative x cubed plus 2x. We can see that this looks like our original function, except for the signs are switched. So if we pull out a negative, we'll be given x cubed minus 2x, which is our original function, so this is negative of the original function. So this means when you insert a negative x, you get out a negative of the function, which we can see makes this symmetric with respect to the origin, which makes this function odd. Let's try g of x equals x to the fourth plus 2. So start with a rough sketch of this, which gives us this. So it appears that the function is symmetric with respect to the y-axis, because it looks like we have a mirror image over the y-axis. Now let's test it algebraically. So inputting a negative x into the original function will give us negative x to the fourth plus 2, which simplifies to x to the fourth plus 2, which we can see is g of x, our original function. So inputting a negative x into the function gives us back our original function, which means this is symmetric with respect to the y-axis, which means this function is even. Let's try one more. h of x equals x cubed minus 1/2 x squared minus 3x. So drawing a rough sketch of this gives us something that looks like this. So it would appear that this is symmetric with respect to the origin, but let's test this algebraically. So we're going to insert a negative x into our function. So it's a negative x cubed minus 1/2 times negative x squared minus 3 times negative x, which simplifies to negative x cubed minus 1/2 x squared plus 3x. So in this case, we can see that this is not like our original equation because the signs aren't just flipped and it doesn't come out exactly like our original equation. So in this case, when we insert a negative x, we do not get out the original function and we do not get out the negative of the original function. So this means this is neither even or odd function, even though it looks like in the graph it would be an odd function.